Hello and good morning and welcome to this Edisam Educators channel. This is Samuel and Ekan. Welcome you to this channel. So in this video we'll be having a physics lesson. The topic is going to be density. So wherever you are in the world, you are welcome to attend and participate. And before we commence, I would like you to actually subscribe to this channel. If you are not subscribe to this channel, hit the bell icon, click on the bell icon and set it to all so that you always be notified whenever I upload a new video. And this is my WhatsApp number in case you want to contact me for anything. +234 803 829 5185. So we'll be looking at density. So what is density? So before we go ahead, let's assume if we have wood and iron, which is heavier? Is wood heavier than iron, or is iron heavier than wood? That question can't be answered because it is actually an ambiguous question. We can't say that wood is heavier than iron, and we can't say that iron is heavier than wood. I know a lot of people say iron is heavier than wood, but how about, let's assume we have a log of wood, a tree trunk, and we have a little piece of iron, just like my wrist, and we have a tree trunk of wood. The wood is going to be heavier. So the reason why we can't actually say which is heavier between iron and wood is that we don't have a basis of comparison. Before we can say that iron is heavier than wood, there must be a basis of comparison. We have to take the same size, the same quantity of iron and the same quantity of wood, and from there we will actually know which one is heavier. That is where density, the word density, actually comes in, because density actually compares how different materials are heavier, but using a basis, the volume, the same volume. It takes the volume into consideration. So if we take a certain volume of wood and the same volume of iron, and we now measure the mass, the one with the greater mass for the same volume definitely will be the heavier substance. In this case, definitely, if we do that for iron and wood, we discover that iron is heavier than wood for the same volume. Iron is what? Heavier than wood for the same volume. So in case you don't know what volume is, what is volume? Volume is the amount of space occupied by a three-dimensional solid. The amount of space occupied by a three-dimensional solid is the volume. Volume is what? The amount of space occupied by a three-dimensional solid. Okay, so when you take a certain volume of iron and the same volume of wood and measure the mass, the one with the higher mass, greater mass, is definitely the heavier one. So that is where the word density comes into play. Density compares mass of different bodies, taking into consideration the same volume. Density is the word we are going to use. So the question I asked at the beginning, that which is heavier, should have been which has a higher density. Is it iron? Is it wood? Because density actually compares the mass of the same volume of different substance. So when we take the same volume of iron, take the same volume of wood and measure the mass, we discover that iron has a greater mass. So the word we should have used is which has a greater density. Is it iron? Is it wood? Definitely iron has a greater density. So when we are trying to compare the mass of different objects, we have to take volume into consideration. We have to take the same volume, and we are going to use the word density. That is where the word density comes into play. So what is density? How do we define density? Density can be defined as a mass per unit volume of an object. We can actually define density as the mass per unit volume of an object, of a body, of a substance. The mass per unit volume of a body, of an object, of a substance. So density can be defined as the mass per unit volume of an object, of a body, or of a substance. Mathematically, density is written as is equals to mass over volume. Density is equals to what? Mass over volume. So density is represented by the symbol, the Greek symbol rho. The Greek symbol rho is used to represent density. Then we represent mass with small m and represent volume with capital V. Okay, so what's the unit of density? The SI unit of mass is kilogram. The SI unit of volume is cubic meter. So at the end of the day, the SI unit of density is kilogram per cubic meters, or kilogram per meter cube. Kilogram per cubic meters, or kilogram per meter cube. That is the SI unit of density. So there is another unit, common unit, which is sometimes used. That is gram per cubic centimeter, or gram per centimeter cube. So that is gram per cubic centimeter. So how do we convert from kilogram per cubic meter to gram per cubic centimeter? So to convert, all you need to do is that we're going to have the density in gram per cubic centimeter multiplied by 1000 gives you the density in kilogram per cubic meters. When you multiply the density in gram per cubic centimeter by 1000, it gives you the density in kilogram per cubic meters. Okay. So that is how you actually, if you also divide the density in gram per cubic centimeter by 8000, you get the density in kilogram per meter cube. Okay. Definitely we know that 1 kilogram is 1000 grams, and 1 cubic meters is 10 raised to power 6 cubic centimeter. So we can use this to do the conversion. Okay, so let's assume we have 1 kilogram per cubic meters. So kilogram is 1000 grams, while this is a 10 raised to power 6, that is 1 million cubic centimeter. 3 zeros cancel 3 zeros. At the end of the day, what do we have? We have 1 over 1000, which is 10 raised to power minus 3 cubic centimeter. Sorry, gram per cubic centimeter. So when you divide this by 1000, divide the density in gram per cubic centimeter by 1000, you're going to land on the density in kilogram per meter cube. When you multiply it by 1000, you will land on this one. So those are just the conversion factors. So we'll briefly look at the density of some substance and try to look at derive one or two things from there. We're going to look at iron, density of iron, mercury, sulfuric acid, gold, silver, and the rest. So We're going to move there right now. So right here we have the density of some elements, some substances. So we have gold. Density of gold is 90,300 kilogram per meter cube. Density of silver is 10,500 kilogram per meter cube. Density of aluminum is 2,710 kilogram per meter cube. Density of mercury is 13,500 kilogram per meter cube. Density of water is 1,000 kilogram per meter cube. Density of sulfuric acid is 1,830 kilogram per meter cube. Density of air, a gas, is 1.225 kilogram per meter cube. Density of oxygen is 1.331 kilogram per meter cube. Density of nitrogen is 1.2 kilogram per meter cube. So if you look at this table now, you look at so far based on what we have here, the substance with the high density based on what we have here is gold, followed by mercury, silver is high, aluminium. Among the metals we have here, aluminum has the smallest density. So then going down further, the density of the gases, air, oxygen and nitrogen, are very, very small. Air is 1.331, oxygen is air is 1.225, oxygen is 1.331, nitrogen is 1.2. Then in between, we discover that if we compare solid, liquid and gas, that gases has the smallest density, followed by liquid, then the substance with high density are actually the solids, okay, the metals. Okay, so but you discover that mercury is a liquid, but it has a very high density. Why? Mercury, even though is a liquid, is actually a metal. Mercury is a metal, so that's why the density is actually very high. Okay, so that means, looking at this density now, if you take a volume of gold and take the same volume of aluminium, gold is going to be very, very heavy. So because this is 1 meter cube of gold, 1 meter cube of gold has a mass of 19,300 kilogram. If I tell that the density of gold is 19,300 kilogram per meter cube, what this means is that 1 meter cube of gold weighs 19,300 kilogram, has a mass of 19,300 kilogram. So aluminum has a density of 2,710 kilogram per meter cube. This means that 1 cubic meter volume of aluminum has a mass of 2,710. So gold compared to aluminum is lighter, very, very light. Okay, so look at mercury. Mercury is going to be very, very heavy. Okay, let's go to water and sulfuric acid. Water has a density of 1,000 kilogram per cubic meters, while mercury has 1,830 kilogram per meter cube. So if you observe, a little ball of mercury in your lab is very, very heavy. When you carry it, you discover that it's very, very heavy. Why? Because of the high density of sulfuric acid. So the higher the density of a substance, the higher will be the density. The higher the density of a substance, the higher will be the mass per unit volume. If we look at things like water, petrol, and oil, the density of water is higher than the density of petrol and density of oil. So if you have, let's say you have a 20 liters rubber container that contains oil, water, one contains water, one contains petrol, another one contains oil. The one containing water is going to be heavier because water has a higher density, 1,000, compared to oil, which density is going to be like 700 and something, 800 and something, and petrol. So density actually determines how heavy something is going to be for a certain volume. Okay, so we're going to move in. How can you actually measure the density of a substance? So that's what we're going to look at next. So to measure the density of a substance, once you know the mass of that substance and you know the volume, you can actually calculate its density. So it depends on the kind of substance. So for you to be able to measure the volume, if for a regular object, a regular substance, what are regular objects? Regular objects are objects that have a regular shape. Okay, you can say that the shape of this object approximates the shape of a cylinder. It approximates the shape of a cube. It approximates the shape of a keyboard. Maybe it looks like a keyboard. It looks like a cube. It looks like a cylinder. It looks like a sphere. It looks like maybe a prism. Might be a triangular prism. Might be a rectangular prism. Pyramid. These are all regular shapes. It might be an hemisphere. So for regular objects with regular three-dimensional shapes that looks like any of this shape, to get the volume, you are going to use the mathematical formula that will be used to calculate the volume of these shapes. Let's assume that we have a shape that looks like a cylinder. So what you need to measure to get the volume of this cylindrical shape, you measure the radius. Either you measure the radius or the diameter. Either you measure the diameter or you measure the radius. Then you measure the height or the length of that object. Then from there, you can actually, let's say, call it height or length, radius or diameter. Once you get the diameter, you can get the radius. That radius is diameter divided by 2. So if it's cylindrical, to get the volume of a cylinder is given by pi r square h. That is pi times square of the radius times square of the height. So with this, you can actually get the volume of that cylindrical shape. Then how do you get the mass? You use a chemical beam balance or any other balance depending on the size of the shape to get the mass, and from there you use this formula. This is equals to mass over volume. You divide the mass obtained by the volume you've calculated by measuring the dimension. You can measure the height maybe with a meter rule, a vernier caliper, micrometer screw gauge. Measure the diameter with a micrometer screw gauge, a vernier caliper or a ruler, a meter rule, depending on how large or how small it is. So with that, you can actually then measure the distance. From there, you can get the density. This is volume of a cylinder. For a cube, volume of a cube is you're going to measure the length of, for a cube, the length is equals to the breadth is equals to the height. So if the length is equals to L, then the breadth also equals to L. The height will be equals to L. So the volume is going to be equals to L times L times L, which gives you L raised to the power 3. For a keyboard, you're going to measure the length, the breadth, and the height. So the volume will be given by length times breadth times height. For a sphere, volume of a sphere is equals to 4 over 3 pi r raised to the power 3. So you have to measure the radius of that sphere. You can use a micrometer screw gauge. You can use a vernier caliper, depending on how large the sphere is, to do that. Okay. So with that, those are the various ways you can actually use to get the volume of that shape. Okay. So those are the various ways you can actually use to get the volume of that shape. So all for a regular shape, all you need to do is to get the volume, measure the dimensions, either with a meter rule, vernier caliper, micrometer screw gauge, and then you now measure the mass. using a chemical beam balance or any kind of balance depending on the size. And from this formula you calculate the density. Okay, so how about an irregular shape object such as a stone? If you have a stone which is not regular, thereby you can't measure the dimensions, how are you going to get the density? You can use a displacement vessel or an eureka can. So we are going to look at that, how you actually measure the density of an irregular shape object. So we're going to do that in the next lesson. So we have actually come to the end of this lesson on density, and we have looked at, we've actually explained density. I've actually explained density, the word density, what it means. We've looked at the density of various substances, various elements, and I have actually explained how you can actually obtain the density of a regular shape object. So watch out for lesson 2 on how you can actually find the density of an irregular shape object. So, and I believe you've actually enjoyed the lesson. So in case you're not subscribed, go ahead and hit the subscribe button so that you will always be notified whenever we upload a new lesson. Then click on the bell icon and set it to all so that you will always be notified whenever a new lesson is coming up. So we've come to the end of lesson 1. Watch out for lesson 2, and if you're not subscribed, go ahead and hit the subscribe button. Thank you. Bye.